Well, good afternoon, everyone. Thank you all for taking the time to join us today. It's a pleasure to be in beautiful San Diego and to have the opportunity to speak with you about the bankability of novel energy technologies. So we're going to change pace a little bit, and what we're going to focus on now is to talk about once the technology has been developed, right, either by, say, a startup company or by an established company in a specific market that's looking at entering a new market, what happens? What are the steps that are taken? And how do developers, how do financial institutions, how do investors decide, right, to support the expansion of this technology? I'm going to talk about the experience of Black & Veatch, which is the company that I work for, and Black & Veatch is a large engineering and construction company based in Overland Park, Kansas. And Black & Veatch works in over 110 countries around the world. At any given time, there are over 7,000 active projects in energy, water, and telecommunications. The company's been around for over 100 years, and it's a over $3 billion company in terms of annual revenue. As I mentioned, the three major sectors that Black & Veatch addresses are energy, water, and telecommunications. In the energy sector, the company designs and builds power plants in many different technologies, all the way from traditional thermal power plants to renewable energy facilities, PV, wind, biomass. In water, Black & Veatch designs and builds water treatment facilities for both potable water and wastewater systems for population centers around the world. And similarly, in telecommunications, the company designs and builds wireless telecommunication facilities. I work for Black & Veatch Management Consulting, and our role is to serve as technical advisors to the financial community. So our purpose is to serve as independent engineers, which is a term that you may have heard. So we are hired as technical advisors and provide business and financial advisory services to third parties, which can be large banks, investors, or project developers. In an industry like ours, where there's a very rapid changing business climate, and many technologies are being developed and being proposed for use. Obviously, many of these technologies are unproven in the large scale, and investments in them can be costly. And this raises considerable concern or questions with regards to potential risk in deploying these technologies in projects, given the fact that failures can have considerable operational and economic impacts. The practice that I lead is called independent assessment of novel technologies. The industry jargon for this is bankability. And what we do is we provide an independent evaluation of new products, new processes, and technologies, and also of the companies that are providing these technologies. Most of these assessments are performed at the behest of lenders, investors, developers, and also the technology manufacturers themselves. The intent is to leverage the experience of a company like Black & Veatch. As I mentioned, has over 10,000 employees, most of which are engineers. So they're subject matter experts in many different fields. And we identify, or we help identify, the strengths and gaps of specific manufacturers and specific technologies. And more importantly, we make recommendations as to how to close those gaps. Black & Veatch has been involved in the independent assessment business since 2010. Most of the work that we've done has been in the renewable energy industry, although not all of it. And today, Black & Veatch is considered by many the gold standard in independent assessments. What is a bankability study? In the energy industry, a bankability study, in short, is an assessment of risk. And the overarching question is, will the system perform as expected? As I mentioned, most of the work that we've done has been in renewable energy. Most recently, we've seen significant increase in the energy storage technologies, not just electrochemical, but also mechanical. Also, many different technologies in hydro, both micro and mini hydro, wastewater treatment facilities, and an industry that touches, tangentially at least today, PV, which is autonomous vehicles. So we're seeing a lot of interest in new electric vehicle technologies, including autonomous vehicles and hydrogen fueled. We work with clients that are located around the world, mainly in North America, Asia, and Europe. So the big challenge here is that because the technology is novel, it doesn't have a track record, hasn't been around for a long time. In many cases, it hasn't been around at all. So how do we assess risk? What do we do to identify, what are the areas that a technology would need to improve on in order to be financeable or in order to attract attention, of financial institutions? And in order to do this, we have a process which essentially is a proxy, right, for the lack of extensive field data or field experience. And at a high level, our assessment of novel technology risk covers 5 areas, right? The first area is the design of the novel technology, and I'll get into the specifics in a few slides. Then we also want to understand the performance and reliability of the technology and of their predecessors. Of course, we need to understand the specifics of the manufacturing process. Who is the manufacturer? Does the manufacturer have the capability to consistently make product that meets the quality specifications of the manufacturer or of the developer? Also, what are the requirements for installation, operations, and maintenance of the product in terms of cost, in terms of availability of spare parts, technology, etc. And finally, who is the company that's developing the product or that's commercializing the product, and what is their position in the marketplace? What are their finances, organization and management, intellectual property, etc. As I mentioned, we work with established companies, both outside the U.S. and in the U.S., who are either entering the market for the first time or that have developed a product elsewhere and are looking at the North American market with new product, process, or technology. We also work with startup companies, both in the U.S. and elsewhere, who are coming to market for the first time with a product that they have not manufactured, and in many cases they lack manufacturing experience altogether. So the major challenge, as I mentioned, is the lack of field data, and that is what we attempt to cover or attempt to find a body of information that's able to create confidence in the specific technology. So in terms of the novel technology design, the significant question that we try to answer is whether or not the novel technology design is capable of meeting the technical specifications claimed by the manufacturer. And here we look at a number of items in what we call a technology evaluation matrix, which is developed specifically for each client, for each product. And here we look at things like the product's specification, both from a mechanical design perspective, We look at the specification of major components, which, for example, in the case of a PV module, as we've talked about here, is comprised of multiple elements, all the way from a glass superstrate to the PV cell, which is the active component that we're all familiar with, the encapsulants, the backsheets, ribbons, junction boxes, etc., all of which have their own specifics and all of which have their own risks involved. We also look at the performance specification for the product. In the case of a module, we need to understand how the product performs over time, especially product power degradation, both in short and long term. We need to understand other important elements, like, for example, the power temperature coefficient, other electrical requirements, which could be grounding, etc. And also, from a manufacturing perspective and a deployment perspective, what are the safety implications of this product during manufacturing, transportation, and installation and use. So all of these elements are looked at in detail with information that's provided to us by the manufacturer or that we research independently. The other area that we look at is performance and reliability. And here the overarching question that we're trying to answer is whether or not the performance and reliability meet the technical specifications that the manufacturer claims. And here, again, we look at a number of aspects which are specific to the product, such as what is the performance advantage that the module or the product has over the competitor's products? How has the product's efficiency, in the case of a module, increased over time? So what has been the history of prior generations of the product? Also, what is the outlook? How will the manufacturer further increase module performance and durability over time? Then, of course, we also look at existing field performance data and extended field performance data from prior generation modules with similar designs, either from the same manufacturer or others, and how the product design has evolved over time to accommodate field experience. Similarly, we look in detail at results of testing, such as IEC qualification testing in the case of crystalline silicon modules, IEC 61215, safety 61730 or UL 1703, and the results of additional environmental testing, especially highly accelerated lifetime testing or other durability testing that may have been performed, either by the developer or by third-party labs. And then, similarly, we focus on benchmarks, what products and studies have been used to benchmark the module performance over time, and how does the product compare to, from a performance standpoint, to its competitors in the marketplace. From a manufacturing perspective, we're interested in understanding whether or not the manufacturing operations are capable of consistently delivering high-quality product. And here, our goal is to perform a detailed review of the manufacturing process, all the way from incoming inspection of materials and components through shipping of finished goods. And this includes things like understanding the quality assurance process in place, both from incoming inspection of materials and components through quality control steps during manufacturing, and also understanding how the company or the manufacturer will guarantee that the quality will not decrease as production expands. Another important element is understanding the level of staffing and the personnel training requirements, and also the supply chain. Where are the components coming from? Are the vendors qualified, and how are these vendors qualified, and how is their quality monitored? As I mentioned, installation, operations, and maintenance is another important element, as it's key to understanding how does or what does system ownership entail. And here, there are three major elements. One is installation of the product. What are the installation activities? What are the costs required? And also or what are the scheduled maintenance activities that are required for the equipment? What are the costs? And what are the spare parts requirements? And what is the organization's approach to long-term availability of spare parts? And in the case of PV, and PV modules in particular, this is important. As I'm sure you're aware, most modules today have very long performance warranties that extend to a minimum of 25 years, and some even longer. So what's going to happen over the life of the product, right, as or if these modules require response to warranty claims? Are these modules going to be replaced? Are they going to be repaired? And if so, how is this going to take place and be financed? So all of these are important questions that financial institutions, developers, and investors are interested in understanding. And then finally, the company. How well is the company positioned to meet its objectives in terms of organization and management? What is the financial position of the company, right, and how it's evolved over time? What's its position in the marketplace relative to its competitors? As I mentioned, what are the characteristics of their warranty, and who's backing the warranty? Is there third-party insurance or not? Is there a warranty reserve that's set aside by the manufacturer to service potential warranty claims? What's the company's manufacturing capacity, and also what's its position regarding intellectual property? So all of these are elements that we review in order to establish a picture, right, of what the technology represents, what's its state of development, who's the company that's developing it, and who's going to be manufacturing it. Now, in terms of the mechanics of the bankability process, I wanted to highlight the following, especially because many in the audience, I'm sure, are involved in the development of new technologies and at some point may be interested in this type of activity. So Black and Veatch approaches technology assessments from two phases. The first phase is what's called a bankability workshop that's carried out with companies at an early stage of development of the product to make sure that the process or the development process is being done in a way where there aren't stumbling blocks once the development reaches commercialization. So here, what we do is, again, at an early pre-commercial stage, engage with the client to understand the state of development of the client's technology, also to help them create an evaluation matrix, which means identifying the key milestones that need to be hit to be successful from a bankability perspective, and then together with the client develop a roadmap to achieve a successful bankability study. So typically this is a short engagement that's done, again, at an early stage, well prior to commercialization, and that allows the company to understand what are the specifics that they need to accomplish in order to be successful from the point of view of a financial institution or potential investor. The second phase is the technology assessment itself, the so-called bankability study, and this takes place at the commercial stage once the manufacturer is already making the product. And here, the goal is to understand the client responses, right, to the technology evaluation matrix that we described earlier. So here, this is a detailed review of all of the items that I described. This engagement typically takes 3 to 6 months or 4 to 6 months, depending on the technology and on the geography of the development and the manufacturers. And as I mentioned, the key goals here are to identify gaps within the different areas of the product, design, performance, reliability, and manufacturing, and more importantly, to be able to provide recommendations as to how to close those gaps. This study involves a review of the manufacturing process, which may be in multiple sites. In the case of PV modules, most module manufacturers today have multiple manufacturing facilities all over the world. So this is something that we visit and that we evaluate. We provide recommendations as to how to improve their processes, the company's processes, and then we verify the implementation of these recommendations prior to issuing a final report. So once the company has received a Black & Veatch independent assessment, financial institutions understand this process and know that they've gone through this detailed assessment and that major or any major issue has been identified and has been resolved. So in summary, a bankability study is a component in a financial institution's risk assessment process. It's not the only one, right? Obviously, each financial institution has its own set or has its own processes and its own set of elements that they take into account in making their decisions, but this is definitely one of them, right? The focus on the assessment of the process, product, or technology by a reputable third party. It provides an honest evaluation and a representation of the manufacturer and of the product to the outside world, which is also important from the manufacturer perspective in terms of being able to present a picture, right, of who they are, what their product is, and you know, what are the characteristics of their offering. The purpose of the report is also to help stakeholders, such as developers, investors, banks, etc., to get comfortable with the technology and to help in financing projects using the specific technology. So that's what I wanted to talk about in general terms. I want to use also the opportunity to talk about what we're seeing in the marketplace in terms of new technologies in solar and specifically in energy storage, and where we see significant activity or have seen significant activity in recent months in PV. So in the case of PV components, right, we've talked a lot about modules. We haven't talked much about inverters nor trackers, which have had significant development over the last several years and which we continue to see evolving very rapidly. In the case of modules, as my previous speakers have stated, module efficiencies have increased dramatically over the last 10 years, while module costs have plummeted. And what we're seeing are many new emerging technologies and companies that are developing technologies in different areas, such as PERC, right, passivated emitter rear contact cells, which have been described earlier, and also bifacial technologies, which we're starting to see deploy in larger quantities and being developed by companies all over the world. Another significant area of development, which sometimes isn't addressed or doesn't receive all the attention that, in my opinion, it deserves, are components. Cell and upstream component manufacturers, such as encapsulants, backsheets, and junction boxes, of which we're seeing a significant increase of new manufacturers and technologies, especially in Asia. From the point of view of inverters, inverters have been the most maintenance-prone component in a PV system, and today we still see a significant presence for large-scale central inverters, but we have seen a dramatic increase in the deployment of string and microinverters, and also a shift towards 1500 volt systems in order to lower systems costs and also maintenance costs. So major development areas that we see are string and microinverters, also bidirectional inverters for energy storage system applications. Another area that hasn't received much attention, but which we see many new manufacturers and technologies deploying around the world are trackers. So we're seeing a significant increase in usage due to low cost. And major development areas are rapidly expanding both single-axis and dual-axis trackers. Many manufacturers in Asia, Europe, and North America, and we continue to see this trend growing. So another element that I would like to talk about is energy storage and solar. The variability of solar generation, as has been stated earlier, is one of the greatest limitations of deployment in the electric grid. And solar plus storage has potential in many different markets, especially in those with high cost of energy and time of use rates, like, for example, California. Also, island economies where power generation typically uses distillate fuels, and we're seeing significant growth in those markets. For example, a client of ours in Hong Kong is making significant investments in deployment of energy storage at a utility scale in order to offset investments, defer transmission upgrades, especially in those areas where lines are being overloaded during brief periods of time, and where the investment in expanding a line can be much more costly than deploying electrochemical energy storage. Also, energy storage can add significant revenue streams, right, such as frequency regulation, voltage stabilization, etc. In addition to decreasing the variability of solar generation and controlling ramp rates, which is an important element from a utility perspective. Another significant application that we're seeing is the deployment of energy storage in data centers, right, where data center operators typically obtain very favorable PPA rates because of their steady load. And historically, they've had uninterruptible power supplies used as essentially a stranded resource. And both the data center owners and the utilities that service them are looking at integrating that energy storage capability into the grid. So we're seeing significant potential in technologies such as flow batteries, which are being developed by multiple companies, both in North America, Europe, and more recently in Asia. So I thank you very much for your attention, and I'll be happy to take a few questions if there are any.